Assalamu alaikum and welcome everyone. Today our group will be presenting on OpenMP, focusing specifically on data management. We will cover how to manage shared memory and most importantly, how to prevent race conditions. This is our group members, Turki Shaibi, Hamza Zahrani, Anas Al-Ghamdi, Asil Said, and your presenter Khalid Al-Amir. So what is OpenMP? OpenMP stands for Open Multiprocessing. It is an API that allows us to write software that can do multiple things at once. Instead of writing complex code to create threads manually, OpenMP makes it simple. It's like telling the compiler, take this part of the code and run it in parallel. So why should we use OpenMP? Firstly, it allows the programmer to separate a program into serial regions and parallel regions. And it uses a unified memory model. This means all threads across the same shared memory, making data access very fast. It is highly portable. It works everywhere. Almost all major compilers support OpenMP. It is also highly scalable. The code automatically adapts to the hardware. If you have 2 cores, 20 cores, whatever, the code scales up to them. However, we have to be careful when dealing with shared memory because it might lead to race conditions, which leads to data corruption. First, let's understand the data clauses. We have 4 clauses. The first one is shared. Allows the variable to be accessed by all the threads. The private clause is safer because it allows each thread to create its own instance of the variable. Then we have first private, which is similar to private but initialize a value from the master thread. And lastly, we have last private, which copies the value from the last iteration. So what are race conditions? Race conditions occur when multiple threads access a shared variable at the same time, which might affect the final result. To avoid race conditions, we use one of these 3 methods. First method is critical sections, which ensures a block of code is executed by only a thread at a time. Second one is atomic, which is similar to critical but faster and forces the threads to take turns. The final method is reduction, which combines all the results from all the threads into one final total. And that was our presentation. Thank you for listening.